Newton's second law of motion. Objective: to learn Newton's second law of motion. Motion is the change in an object's position. Sir Isaac Newton, an English scientist, proposed 3 laws of motion that help us to understand how objects behave when they are at rest, or when they move, or when force acts on them. For this session, our focus will be on Newton's second law of motion. This law tells us that an object's acceleration depends on its mass and the amount of force acting on it. It says that the acceleration of an object is directly proportional to the net force on it, and inversely proportional to the mass of the object. Let's put that in much simpler terms. If we increase the force on an object, its acceleration will increase. But as an object's mass increases, its acceleration will decrease. In other words, it's going to require a lot more force to move a heavier object than a lighter object. Let's see how this law works in practice. Imagine there's a 20-pound box sitting in the middle of the floor. If you push the box with your hands, it will slide across the floor at a certain speed. If you ask your friend to help and both of you push the box, it will slide much faster. With 2 of you moving it, the amount of force has increased, causing the acceleration to also increase. Now, if you both push a larger box weighing 40 pounds using the same amount of force, the box won't move as fast as the 20-pound box. But why did it slow down? There are still 2 people pushing it. In this case, the mass of the box has increased and the force stayed the same, so the acceleration has decreased. Let's calculate how much force is required to accelerate our 40-pound box at 4 meters per second squared. We can use the formula F is equal to m multiplied by A, where F is the force, m is the mass, and A is the acceleration. This is the formula for Newton's second law. Let's substitute values that we already know into the formula, and then we can solve for any we don't know. We know the mass of the box is 40 pounds, and the acceleration is 4 meters per second square. When talking about units of force, as we have just solved for in our equation, we refer to those units as newtons, which is abbreviated as N. That means the units of force in our solution, kilogram meter per second square, can be replaced by N. That gives us the force required to accelerate our 40-pound box at 4 meters per second square, as F is equal to 160 N. We could rework our equation and solve for A, acceleration, giving us this equation. A is equal to F by M. And we could do the same thing for the mass by solving for M, mass, with an equation that looked like this. M is equal to F by A. Summary. The second law of Newton says that acceleration of an object is directly proportional to the net force on it and inversely proportional to the mass of the object. The equation used to calculate a force that accelerates a given mass is F is equal to ma. The equation used to calculate the acceleration at a given force is A is equal to F by m.